In this tutorial, we're going to take a look at developing a REST API using the Go programming language and MongoDB, because as of right now, Mongo does offer an official Go SDK. But before we get into the core material of this particular tutorial, I want to give a shout out to DigitalOcean because they are a sponsor of this particular video. If you're unfamiliar with DigitalOcean, they are a great service that offers managed Kubernetes, compute, object storage, and a bunch of other great stuff towards developing and deploying your own applications. If you want to get started with DigitalOcean, I do have a promo code that I can give you. Go ahead and go to do.co/polyglot in your web browser, and you'll get $100 credit towards your account if you sign up. So jumping into the core material of this particular tutorial, you'll notice that I do have my terminal up and I do have a shell client for what is actually Docker open. So I am running MongoDB through Docker. You could be running it locally, you could be running it remotely, maybe on DigitalOcean. That's totally up to you. But the fact of the matter is that I already have Mongo set up. You'll notice in another tab, I am in my Go path. So we will be developing our application here. You just need to create a new directory in your Go path, and we'll want to create a new file in our Go path called main.go. So with this ready to go, let's go ahead and open up this project. I'm going to be using Atom by GitHub in order to do my coding, but feel free to use whatever you want, whatever is most convenient to you. So I do have my file open. Let's go ahead and actually, before we start coding, let's go ahead and get our project dependencies. So there are two dependencies. The first dependency will be our multiplexer for handling our HTTP requests. So we can say go get github.com/gorilla/mux. So this is the Gorilla Mux multiplexer. The next thing we'll want is that MongoDB Go SDK. So we can say go get github.com/mongodb/mongo go driver. Let's see, did I make a spelling mistake here? So I actually messed that one up. It's actually MongoDB/mongo go driver/mongo. Sorry about that. I was confused at what I was typing for a second, but that is actually what you want. So go ahead and do go get with the package manager. Those are the only two dependencies that we need. With those, we can go back into our code and we can start adding our boilerplate logic to our application. So we can add our package, we can add our main function, and maybe we can even do a print message to show that it's working. So we can save it. You can see that my editor does add imports in for me automatically. If yours doesn't, don't worry. At the end of this tutorial, I'll scroll up and you'll have a chance to grab any of the dependencies that might have not been added on your end. So with the line started, we can start. There's a few things that we want to do. We want to establish a connection to MongoDB. We want to define our data model to be used throughout the application and in our collection. And we want to define our endpoints. So what we can do first is we can actually define our model. So let's go ahead and say type person struct. And we're basically going to have one collection. And this collection is going to have a few properties as far as each of our documents goes. And nothing more. We're going to try to keep it simple, but you could easily expand upon this on your own. So we're going to have an ID. This is going to be a primitive, and it's going to be object ID. So this is MongoDB's own object ID for the ID. We are going to have annotations here, so that way we can map our native Go structure between both JSON and BSON. So we're going to say JSON. This is going to be ID with an underscore. Omit empty. For BSON, it's going to be the same. And we're doing this just so that way we have something to play around with, something that prints nicely. And BSON is the official annotation for MongoDB. So that BSON will be used in order to marshal and unmarshal our data structures into something Mongo understands. But our JSON is going to be for something our web browser client understands. So we have BSON, it's going to be ID, omit empty. We're going to have a first name. This is going to be of type string. And we're going to keep it simple. JSON is going to be first name. We're going to have bson. It's going to be first name, omit empty. We're going to have a last name. And you can see where we're going with this. All right, so we have our data model here, which is our structure in Go. The next thing we want to do is we want to create an instance for our client connection. And we're going to do this outside of the main function, so that way it can be used within each of our endpoints. So I'm going to say the following. I'm going to say var client, and that's going to be of type Mongo client. Inside of our main function, we can actually establish the connection. So that way, when we run our application, the connection starts to get established. But in order to do that, we need to be defining timeouts for Mongo and Go. So we want to define what's called a context and then pass that context into our connection. So first of all, it would look something like this. And I'm going to skip the errors. In production, you definitely want to keep track of your errors and respond appropriately, but we're going to skip them for this particular tutorial. I'm going to say context with timeout. The parent is going to be context.background. And then the timeout value, let's go ahead and say that's 10, and that's going to be seconds. With our context value, we can say something like client, which we've already defined, equals mongo.client. We're going to pass in that context, and we're going to pass in our connection string. In this case, it's going to be MongoDB localhost, and we're going to give it the port that it needs. All right. And it's actually not Mongo client. Again, I made another mistake. This is actually mongo.connect. All right. So the next step is, well, we want to define our router. So we're going to say router equals mux.newRouter. And we're going to say http.listen and serve. We're going to listen on port 1, 2, 3, 4, 5. And we're going to pass in the router. So you could go ahead and use the HTTP packages that ship with Go, but I've always found that the Gorilla Mux multiplexer always works out a little easier. So we don't have any endpoints yet. We just have a connection to Mongo, and if we really wanted to, we could run this and it should work out fine. So let's go ahead and say go run, and it says starting the application. Great. Everything should be good. We'll trust it for now. So let's go ahead and start adding our endpoints in. So as of right now, let's go ahead and assume that there's no data in our database. So we're going to create an endpoint for creating data. So this will be a post endpoint, but we're going to say function. Let's go ahead and give it a name. We'll call it create person endpoint. It doesn't really matter what you call it, but we're going to have a response, and this is going to be of type HTTP response writer. We're going to have a request, which is going to be of type HTTP.request. And inside of it, the first thing we want to do is we want to determine what our response type is going to be. The user, we could respond with whatever we want, but the user will probably anticipate JSON because that's kind of the norm lately. So we're going to say response.header.add content type application/JSON. So with the response added, let's go ahead and marshal in our request body, because this is going to be a post request. We're going to anticipate that we're going to get a JSON payload or body. So we need to convert that into an object that we can actually work with in Go. So we're going to say var person, type person, and we're going to say equals JSON new decoder. This is going to be request.body.decode, and we're going to decode it right into that person. All right, so that would be whatever the user passes into us, and technically we don't need this. Let's just go ahead and skip it. Let's go ahead and now what we want to do is we want to query the database. Well, not query, but we actually want to open our collection. So let's say collection equals client.database. Right now, we're not gonna we're just gonna hard code the database in each one of our endpoints Typically, you'd probably want to do this globally. Just like for the context, you could probably do this globally as well, so that way it's kind of universal for everything. But for this example, we're just going to hard code it right in. So we're going to say the polyglot developer. That's going to be the name of our database. And I'm going to use the collection people, plural. So we have our collection. The next step is to define the timeout. So I'm just going to copy and paste it. And once we have that timeout, we can say something like result collection.insert 1, provide that context, and provide whatever we're planning on inserting, which would, in this case, would be person. And then finally, it might make sense to actually return the results of that insert. And Mongo will return something special. So let's go ahead and say json.new encoder. We're going to say response encode result, and I'm going to save it. So as of right now, all should be good. So we don't have anything hooked up to this function. So let's go ahead and add that. So what we want to do is we want to create our path. We want to define what method can access it, and then we want to link up that function. So we can say router dot handle function. The path, let's go ahead and say this is going to be person. We're going to be passing in one particular person. Just added a little bit more than we needed to here. But this is going to be create person endpoint. And for methods, it's going to be a post method. And I'm going to save it. So at this point, it probably makes sense to actually run this. Let's go ahead and go run it. I'm going to open up Postman. We're going to switch this to a post request. I'm going to say localhost 12345 person. For the body, this is going to be a JSON body, and I'm going to provide a first name, which is going to be Nick, and a last name, which is going to be Raboy, and I'm going to send it. And you can see that I now have an inserted ID. So if I had to take a wild guess, I'd say that this insert probably succeeded. So with that, rather than looking directly in our database, let's go ahead and create another endpoint. This endpoint is going to be responsible for getting documents from our collection. So let's go ahead and create another endpoint. I'm going to call it function. Let's say get people endpoint, plural people, response http.responseWriter. And this is going to be a request, http.request. Again, I want to define what the response format is going to be. In this case, it's going to be JSON. And this is going to be where things get a little complicated. Because with MongoDB, you will be working with cursors for all of your data, similar to how you would with a relational database. So if you've ever worked with Oracle or Java like I have, you're probably familiar with working with cursors and having to iterate over them for your results. It's not a big deal. It just adds a little bit of complexity to your actual code, and it's not really complexity, it's just length to your code. But what we want to do is we want to say var, we want to say people. This is going to be a slice of person, and we're gonna establish our collection, which is going to be people again. So collection equals client.database. Again, the polyglot developer, which could be hard coded or put into a configuration file or passed in. And this is going to be people, which could also be in a configuration file as well. We're going to define our context. So let me just copy this line again. And we're going to try to actually do a find. And we're going to end up with a cursor. So we're going to say cursor. We will catch our error this time. Collection dot find. So this is going to be our context. And then we're going to say bson dot m with an empty object here. And what we're saying by doing this is we're saying, you know what, return everything in our collection, because if you've worked with the other languages before, you can generally pass in the query parameters, or even if you're using the Mongo shell. Right now we're just doing an empty object, which would be everything. Let's go ahead and spell cursor correctly so that way it doesn't cause me problems down the line. But let's go ahead and now first check to see if there was an error. So if error not equal to nil, then what we can say is we can say response dot write header We can say HTTP dot status internal server error if we want. That should be HTTP. So there are default kind of server errors here. We're going to say response.write. This is going to be a byte slice, and we're just going to say this is going to be message, and we're going to say error.error. So we're going to return the string. And we're doing this because we want to return JSON, because this is what we expect as far as our header goes. And then so that way the rest of our code doesn't execute, we're going to return out. But assuming that the error didn't trigger, let's go ahead and proceed as normal. So when we're done with the cursor, when we're done with this function, let's go ahead and close it. So we can say defer cursor.close, passing in the context. And we're going to loop through that cursor now. So we're going to say for cursor.next. I'm going to provide the context. We're going to say var person, which is of type person. We're going to say cursor.decode. We're going to decode the current value in that cursor to the person variable. And we're going to append it to our people slice. So people equals append people person. And because remember, we can't just assign it all to this person slice, because it's not going to be formatted correctly. It's going to be formatted in terms of Mongo cursor language, or whatever you want to call it. So we do have to loop through that cursor, and we do have to store each item to be returned. So we're adding it there. After we're done with that, after we've populated that people slice, we're going to check to see if there are any errors with the cursor, because these would be different than the actual find statement itself. So we're going to say if error equals cursor.error. We're going to say error not equal to nil. And we're going to say, let's go ahead and return an error. So let's go ahead and copy what we have here. Save us some typing. We're going to say, yeah, this could be a server error, and whatever the error is, let's go ahead and return the message and return it. So just more error handling. I know I said that I wasn't going to do it, but this kind of makes sense to do the error handling here. And then finally, if everything went smooth, what we can do is we can say JSON new encoder response encode people and save it. So let's go ahead and restart that application here. I'm going to run it. This time we should still have one item in the database, so I'm going to say this is a people endpoint now. This is going to be get. And I'm going to say send 404 not found. Yeah, so it's not found because I never actually configured it. We created the function, but we never hooked it up. So let's go ahead and hook it up now. I just cloned that line. I'm going to call this people plural. So this is going to be the get people endpoint. And this is going to be a get method. So let's try to run it now. It should work this time. So going back to Postman, I'm going to hit send, and it returned one item. So remember, my native Go data structure, it includes an ID, includes a first name and a last name. It could easily include more. It doesn't matter. But the fact of the matter is we have one item in the database, and it returned it as an array. So far, so good. Let's go ahead and add another endpoint, so that way we can actually make use of our query a little bit better. This time around, we're going to query for one particular entry. So let's go ahead and create another endpoint function. So we're going to say, and actually what I want to do is I'm just going to copy and paste. So I copied one. This is going to be, instead of create person, it'll be get person. So person singular as in one person. And we're gonna do some minor changes inside of here. So we're returning application JSON. We're going to say params equals mux vars request, and the reason why we're doing this is because we will have route parameters in the request that we're going to extract. So it's not just going to be a request body. We're going to say ID equals primitive dot object ID from hex. And the reason why we're doing this is because we're going to be passing in an ID, and we need to actually convert it into a usable MongoDB object ID. You can't just use a string. You have to convert it. So params ID We're going to say var person, and we are going to set up our context, and we're going to set up our opening of the collection, so we can copy and paste that again. So I copied and pasted it. We're using the Polyglot developer database. We're using the people collection, and we're setting up our context. With that out of the way, we can say error equals collection dot find one, and we're going to say pass in our context, and we're going to pass in our search. Remember how we use bson.m above. This time we're going to be a little more specific because we've modeled our data structure after our collection. So what we can actually say is we can say person. We're going to provide an ID, and we're going to use the ID that we had set on line 62. And when that's done, we're going to decode it into our person object that we had set up. If there was an error, then we're gonna return a negative response. So we can just copy this again. We're not using a cursor this time because we're only finding one record. But if there's an error, we're going to return it. Otherwise, json.newEncoder response encode person. Let's go ahead and save it. I'm going to run it, and then I'm going to revisit this to just kind of reiterate some things. So I'm going to restart it, go back to Postman here. I'm going to copy this ID. I'm going to change the endpoint here to person, pass in that route parameter. It's going to fail again because I just realized that I didn't create a route for it. So let's go ahead and create that route. This one's going to be person, and we do need to configure an ID. So we need to say ID. This will be get person endpoint. If I restarted it now, it should work. So run it, and I get one record back. It's not an array, which is good. So you'll see that this right here is ID. That matches what we have in our request parameters. They could be named whatever you want as long as they match. But just to reiterate here, and this is something that kind of threw me up for a little bit. I had a tough time understanding it based on the documentation that was available. You can't just say bson.m and then pass in some parameters. It didn't work that way. What I had to do was I had to create, I had to use the person object. I had to use the person data structure. I also had to not use a string. I had to convert it into an actual object ID. So those threw me up for a little while. Now, if you wanted to, you can continue to go down the line. You could add update, you could add delete. It's more or less going to be the same thing. Update what you would do is you would first get a document based on kind of like this get person endpoint, then do a change, so on and so forth. But it's not too difficult. But just to kind of rehash here, we did do our annotations for bson, so that way we could easily map our documents to our Go data structures. We established a MongoDB client, which we connected to at the bottom here. We did have to work with the context. We created 3 endpoints using the Gorilla Mux multiplexer. And then in each one of these kind of queries or endpoints, for example, insert 1, we just used the person payload because it was correctly mapped with bson. For get people, it was a little more complex because we had to use a cursor and loop through. And you could edit this. You don't have to return everything. You could return more than one document based on some parameters. But inside of the get person, we just got one particular document. So this is some pretty powerful stuff. You could easily host this on DigitalOcean or wherever is convenient for you. But at least now you have an idea on how to use Mongo with the Go programming language.